This conference will now be recorded.
Good morning, everybody, and thank you for attending our Cost of Corrosion webinar. My name is Mark Rothenberg. I am the president of Intercept Silver and Jewelry Care, and it is my pleasure to present to you our lead engineer, Keith Donaldson, and he's going to make today's presentation.
Thank you very much, Mark. Good morning. Thank you very much for joining us today. The topic for today is talking about microcorrosion, basically what we know as tarnish in the jewelry world. I think back to 2 years ago when I was invited to China to be the keynote speaker for 78 museum curators from around China. The topic of the conference was uh, their ancient bronzes. In China, they are losing 1 to 2% of the mass on ancient bronzes currently, no matter how they're protected. What that means is instead of just having tarnish on these bronzes, they are actually losing material on a yearly basis. Things that existed for 1,000+ years are now suddenly disappearing. That's kind of a gross version of what we're talking about. And what we're here to talk about is a form of that. Basically, the environment is getting much worse around the world. It's attacking things like it never has in the past. For us, tarnish is not just a mere inconvenience. Obviously, if you have silver flatware, silver jewelry, you know that they do tarnish and they get darker with time. The problem is to actually clean that tarnish off. We're not just rubbing the surface, we're actually removing silver. We're we're removing metal. And as we clean, as we buff, there's only two ways to remove tarnish from the surface of a piece of jewelry or silver flatware. It's either to chemically reduce it, so using chemistry to basically eat away and remove that tarnish layer to get down to a fresh metal layer, or you have to physically remove it. But in either case, you're looking at removing metal and reducing the mass, just like they were finding in China with their bronzes. Corrosion is on the rise around the world. Certainly when we look at the 2016 cost of corrosion, we can certainly see that number very clearly. $2.5 trillion is lost due to corrosion back in 2016. When we step back a few years and just look at the US, we're looking at basically $1 trillion worth of loss due to corrosion, due to tarnish. Um, and if you put that in comparison to just 15 years earlier, you see that the number ballooned from 276 billion to 1 trillion. And the reason for that is because the environments in the world are getting more corrosive and we're subjecting our materials, our silver, our jewelry, to a more aggressive environment. So it basically is costing every one of us uh, both time as well as money. Corrosion is basically constant as around us. Corrosion, again, is the same as tarnish. Basically, we have to look at what causes metals to tarnish, what causes them to corrode. Only gold and platinum actually exist in nature as pure metals. They come out of the ground as gold and platinum. Everything else comes out of the ground as something else, a salt, an oxide, some kind of compound that we need to basically process, we need to refine, we need to make it usable for our operations, for our products. This process, once we make the metal the way we want it, suddenly the corrosion cycle starts. Nature wants to return it to the way it was. This corrosion cycle can't be stopped, but it can be slowed down. And that really is a basis of what our presentation is this morning. How do we slow down that process so that we can get the maximum useful life out of the products that we're manufacturing and selling to our customers. What we want to do now is concentrate basically on the 4 R's of the cost of corrosion on jewelry. Those 4 R's being repairs, replacement, reputation, and risk. We're going to start with repairs. In some cases, tarnished jewelry can be repaired. It can be repolished, it can be chemically cleaned, so we can return it to the state that it looks pristine. Because we have to remember that unlike other items that consumers buy, that they put on the shelf or is just there to look at from a distance, jewelry is worn. So people have a much higher level of critical analysis, critical feel for what the jewelry looks like on them. So they will see things that ordinarily they wouldn't comment about. Suddenly, when they're wearing it, they do see it, and it's problematic to them. One of the other issues with repairs is the fact that sometimes there's other settings and other materials on the jewelry that don't lend themselves very nicely to the heat involved in repairs, certainly not the chemicals involved in trying to clean up the silver or the different jewelry. So sometimes our designs and the jewelry itself, because of what's on it, don't lend themselves very nicely to repair. So suddenly you're in a situation that you have an upset customer and there's not a lot that can be done in regards to repair. Suddenly we find ourselves into the second R, which is replacement. Obviously, when we get into the replacement, suddenly we've not only lost the value of that jewelry item, we're also inconveniencing dramatically the customer. Obviously, the cost of replacement is extremely high, simply because we're having to replace what had already been built once, and then we had to figure out how to get value back out of the item that we're replacing, because obviously it can't be resold as a new item. The cost for replacement can be overwhelming to customers, but more importantly, is overwhelming to both the retailers and the manufacturers of the items. That leads us into the third R, which from a retailer and a manufacturer is probably the most expensive. It certainly does not cost the customer anything to tarnish our reputation, but when they get jewelry that does not meet their expectations due to tarnishing on the item coming in or issues with the item coming in due to corrosion, suddenly in this world of mass media, they get their word out that their dissatisfaction. What we're finding is that in the past, people may tell one or two friends that they know. Now the reach that these people have that are dissatisfied with the product or with the service, suddenly they can reach around the world. So the loss of reputation can occur extremely rapidly and can be quite devastating, both to the local merchant as well as to the manufacturer of the item. Obviously, it's easy to control the cleaning of jewelry in your shop, the repair. Controlling the loss of your reputation is much more difficult to handle, much more difficult to repair, and again, far more costly. That's why in our mind, when we look at the 4 Rs, just kind of recapping what each one is costing and what each one does, repairs obviously cost our customers time and frustration. It doesn't necessarily cost them money, except when you consider that their time is also valuable to them. So there is a cost component for the customer having to go back to a shop or having to return an item to be cleaned. As far as on our end as manufacturers, as retailers, it costs us money. It costs us a little bit of money because there's time associated with cleaning. Replacement, now suddenly we're into costing your customer additional time, additional frustration. When they have to have an item replaced, suddenly their level of satisfaction with that item drops. So there's a lot of hidden costs to the customer that we can't really categorize, but certainly they are feeling. Now, to our end of it, it costs us a lot of money. Whereas cleaning is relatively controlled, it's in-house oftentimes. When we had to replace, again, suddenly we lose the value of that original item, and which obviously is the full profit on it, but we're also having to provide a replacement to it and try and figure out how to extract value back from the item that was just replaced. Reputation, it doesn't cost the customer anything to trash a reputation. Sometimes they do it because they're so frustrated and upset. And again, the reach that customers have now with mass media, with social media being the way it is, suddenly it can be very swift and very quickly go around the world. The cost to the companies for loss of reputation, it's really difficult to know what that is. It can be minor, or it can also be a major cost and a major issue that needs to be addressed. Certainly, consumers look at ratings, they look at complaints, they look at how other customers feel about the companies that they're dealing with, buying from, and the products that they're getting. So the loss of reputation has, again, just potentially huge costs. When we look at the fourth R, that fourth R being risk. The nice thing about risk is this has the biggest potential because at this point we control the risk. This is where we come in and can help mitigate potential losses, mitigate or eliminate the need for repairs by controlling risk and understanding it and applying properly the principles to reduce risk. We can also reduce the potential for the replacements, all of which help to secure our reputation that we've spent years and years working on developing and keeping. What do we mean by risk, and what do we mean by that we control this particular cost of corrosion? We control it by using or not using proper protection, proper packaging designed to protect the jewelry and the silver going into it. We obviously have lots of choices in life. We have choices in the boxes we use, in the construction of the items that the jewelry is being held in, shipped in. That will be a topic of future webinars, talking about the packaging itself, the intimate packaging to the item. What we want to talk about today, and the whole basis of this webinar, is to talk about reducing risk by using the proper right corrosion inhibiting process and the corrosion inhibiting product. There's 4 basic types of products on the market to prevent tarnish. We obviously have 5 choices here. One choice is not to use anything, or the products out there are charcoal paper, volatile corrosion inhibitors, often called VCIs in the marketplace, but that VCI actually stands for volatile corrosion inhibitor. Coatings, obviously expensive. And then the fourth way is a copper-based anti-tarnish poly tabs and bags. And this is one of the things that we're going to actually concentrate on right now, is what we call Corrosion Intercept, which is a copper-based product. Corrosion Intercept was developed by Bell Labs, They developed it for their own applications. They developed this back in the mid 1980s when there were changes in their industry in telecom, as telecom moved away from using gold in their telephones and in their circuitry. The problem is once you move away from gold, corrosion and tarnish becomes a big issue with electronics. They needed to find the best way of protecting against corrosion. They needed to do that in order to keep their equipment functioning for as long as possible and to keep the telephone system up, because obviously people demanded high reliability from the telephone company. That has not changed. But what did change is moving away from gold, again, created an issue with corrosion. Bell Labs had a lot of resources back in the mid 1980s. They looked at all the different products on the market. They analyzed each one, looked at the pros and cons of each one, and decided that there was not a single product on the market that met their very high criteria, their high threshold for what they required for their products. So Bell Labs went back to doing what Bell Labs does best, which is creating technologies. They looked and they were able to develop a way to take a highly reactive copper material, highly reactive copper particle. The copper particle is about a fifth the width of a human hair. It's extremely small, but extremely high surface area. They actually discovered a way of putting this copper into a plastic where it becomes part of the plastic. What that does is allows this sheet of plastic to act like a sheet of extremely high surface area, highly reactive copper that acts as a preferential corrosion site. It acts as a barrier to the things that cause corrosion, but it also acts like a plastic, so it can be conformable. It can be made into bags and other products. So that's the basis of what we have. The interesting thing about Intercept, and Corrosion Intercept in particular, is its properties. One of the things that Bell Labs wanted was something that would work in every environment. Intercept is the only anti-corrosion material that is being used in all 7 continents. And I did say 7 continents. It actually is being used by the British Museum down in Antarctica for some of their storage items down there dealing with the Lord Shackley. So it's used everywhere from extremely cold. It's the only anti-corrosion material that will work at temperatures as low as minus 42 degrees Fahrenheit. It's also used in places like the Middle East, Africa, Australia, that get extremely hot and extremely humid. Obviously, humid places like Singapore, China. The nice thing about Intercept is it not only works extremely cold temperature, it works at extremely hot temperatures. As temperature increases, the rate of corrosion goes up. What we find with materials as you clean them, basically you're micro scratching the jewelry, which opens up surface area, which causes even faster corrosion formation. Likewise, when you increase the temperature, the things that cause corrosion, such as sulfur, chlorine, ozone, nitrous gases, all those gases become far more active, far more reactive. So what happens is temperatures increase, you have this increased corrosion rate on our items. The nice thing about Intercept is as the temperature increases, the reactivity of the corrosion intercept also increases. So it keeps up with the pace of the more aggressive gases. It still has the ability to scrub them out and to keep them away from our jewelry. This effectiveness is not impacted by low or high humidity. It really doesn't care what the humidity is. One of the best things about Intercept is it contains no volatiles. Nothing can come out of Intercept. Things go into Intercept, react, and are permanently neutralized there, but no volatiles, no VOCs, which what we call volatile organic components, can come out of the film. So it's completely inert to people handling it to the jewelry. And the other nice thing about it, it has no odors and it has no greasy feel to it. It is safe for all metals. It works for all metals. It's safe for plastics, mixed media, because one of the things with jewelry nowadays is things are getting more complex. Um, People are putting things together that ordinarily in the past wouldn't necessarily have been joined together in different jewelry. But the nice thing about Intercept is it's safe for all of that. Intercept's fully compliant with all US and European health and safety and environmental regulations. That's extremely critical when it comes to product that goes around the world. You always want to make sure that whatever packaging you're using is compliant in the different countries. Europe tends to be the most aggressive about environmental and health and safety right now. We are fully compliant with them. We keep up to date with all the changes in their regulations and always ensure that Intercept is a compliant material for them. Obviously, by being compliant with the health and safety, we are safe to handle. We don't want to eat it, but otherwise, it's safe to handle. We don't have to worry about anything coming out of the material. It is fully recyclable as a number 4 colored polyethylene, which is the most that's the easiest material to recycle because it can go into all sorts of different polymer streams. So it's easy to recycle. So from an environmental side, it has a very low impact on the environment, which is very good for obviously most of the customers that we're selling to. They do have sensitivity to how plastics are being perceived and how plastics potentially can harm the environment. Intercept is not harmful to the environment simply because it's recyclable and it does break down in landfills if it's not recycled. The other nice thing about Intercept is it has a long, stable shelf life, which from a manufacturer, somebody that's manufacturing jewelry or shipping jewelry, the nice thing is you don't have to worry about the materials on your shelf going bad. Intercept is extremely stable for years and years before it's put into use. And once it's put into use, it has an extremely long effective life as well. And most importantly, we save one of the best for last. It doesn't scratch the jewelry, which obviously not only takes away from the appearance of the jewelry if it gets scratched, but when you scratch, you also increase the rate of corrosion on that jewelry, just like buffing would do. That increases how quickly something's going to tarnish again. By not scratching the jewelry, we keep it pristine and delay that whole process of tarnish. Looking at the 3 different technologies and kind of contrasting them, we go through this quickly. Future webinars will get into not only the causes of corrosion, but get in more depth into these different products. The first one is carbon paper. Carbon was designed for the oil industry. It was designed for very high levels of contamination, for taking contamination out of oil and gas. So it's designed for very, very high concentrations of gases, far higher than anything that we're ever going to experience in any environment that this jewelry could possibly be seen in. Wide temperature range? No. It has a very narrow temperature range. In fact, if you increase the temperature, whatever the carbon has absorbed, it will release. So you can actually get release of high concentrations of gases right next to your jewelry. Uses chemicals. Carbon paper doesn't really use chemicals except for carbon, but it can release those gases that it traps, so it can be seen as something that outgasses. It is abrasive. Carbon tends to be very abrasive. It's a very hard material and it can scratch. It has potential leaving stains on. Again, that has to deal with if you raise the temperature, the carbon will release the gas as it's absorbed. Hypoallergenic, possibly. Again, it depends what the gases it's absorbed and people's sensitivity to those gases. It is recyclable, but it does not work at normal pollution levels. Carbon paper is tested typically at levels of gases that would kill everybody. At those kind of levels of contamination that you find in oil and gas in its raw form, works very effectively. Below about 5 parts per million H2S or sulfur, it tends not to work particularly effectively. And that has been shown in museums around the world. It was better than nothing, but its level of effectiveness is very compromised. The next one we want to talk about is VCIs, or volatile corrosion inhibitors, all the way over on the right-hand side. VCIs basically are designed by putting a liquid into either paper or plastic. That liquid comes out and coats the surface of the jewelry we're trying to protect. It works by coating and changing that surface chemistry. It has a very limited range of temperatures it works in, typically between 55 degrees Fahrenheit and 85 degrees Fahrenheit is where the effective range is for these volatile systems. It does use chemicals. That's the whole idea. Chemicals that do have potential health and safety issues. We would direct any questions on that to SDS sheets and to different regulations around the world. If you're using a volatile system, definitely check the SDS, the safety data sheet, look into the chemicals being used, because there are potential health and safety issues with some of those chemicals. Abrasive potentially, again, particularly in the paper form, but even the plastic. Again, it has to do with the things that need to be put into the plastics in order to get them to function properly with the volatile oils that are going into it. Hypoallergenic, typically no. There is about 10 to 12% of the population that will react negatively to the things used in volatile protection. Things like contact dermatitis have been known to happen. Again, we have to remember that what we're protecting is going to be potentially worn. So that's something that should be considered and thought about. Recyclable, typically no, because the chemicals involved. Works at normal pollution levels, yes. And the other product that we want to just briefly go through is our Intercept. In this case, Intercept poly tabs, which are dark brown in color. The Corrosion Intercept tends to be copper in color. Our Static Intercept is dark brown in color. The difference between the two is that the Static Intercept has more copper in it, and that's why the color shifts. We put more copper in to make it better for electronics. It provides more what we call protection for ESD. But for jewelry, what we find is that additional copper content required for electronics helps provide actually even better corrosion protection for the items we're trying to protect. Wide temperature range, we've already talked about that, minus 42 degrees Fahrenheit up to 165 degrees Fahrenheit. Basically all the possible ranges of temperature that your products could see, even if it's going in a hold of an airplane, which typically can get down as low as minus 30 degrees Fahrenheit. So even in an airplane hold, Intercept continues to work. We use no chemicals. It has no outgassing. It is approved for space flight by NASA. It's extremely clean. It's one of the cleanest materials on the market for it is the cleanest material on the market for anti-corrosion. It's not abrasive. It leaves no deposits. Hypoallergenic. It's recyclable, and it works at normal pollution levels. Again, prevention is the best course at trying to slow down corrosion, slow down tarnish. That is controlling that last R, risk. If we can keep the items looking pristine, looking the way that they were when they were made through that ship store cycle, so that the customer opens it up and sees it the same way as how we manufacture it, That is what the goal is, and that is what Intercept delivers. At this point, we want to thank you very much for your time this morning. We want to encourage you to reach out and contact us for further information. Any questions that you may have had through this webinar, we're happy to answer. We're happy to give you more details and more information about. But the big thing is contact us. Let us know that you have questions. Let us know that you have interest. We're happy to discuss this further and discuss how Intercept can help in your particular application. Thank you very much for your time.
Thank you, Keith Donaldson. Appreciate your presentation. I hope you all found it extremely useful. If you'd like to schedule a 15-minute call or want to email me, my link information is on the screen as you see it. And again, thank you very much, everybody, for attending, and I hope you found this very informative and helpful, and I hope to hear from you soon.
Thank you.
Thank you.